Okay, so this is a very similar question to similar to the one that we did some time ago. That is question number one, which is basically based on travel of a body, motion of a body from point A to point B, but in equal intervals of time, right? Here, instead of equal intervals of time, we have been given equal distance, one third of the distance, the second one third distance, and the remaining one third. So, what I would suggest is pause this video, take down the question, and try solving it. And as usual, don't try to mug up the formula by referring other textbooks. Just do this one step. Average velocity is equal to the total displacement upon the total time. And how we'll do this? You'll first draw a rough diagram, mark it, mark the point, initial point as A, final as B, the midpoint as C and D, and then you can, excuse me, and then you can figure out what is the total displacement, mark those displacement, and then mark the individual velocities. It will be easy for you to solve the question. So pause the video now, start doing it on your own. So if you have done the question, it would look something like this. Let me just draw a rough diagram here. So this is the rough diagram. So the body is moving from A to B in equal distances. So let us say this was C and this is D. Okay. So A to B, let me take this entire distance A to B as 3x. In which case, how much would be A to C? It would be x. How much would be C to D? You are correct, x again. And how much would be D to B? Right, x again. Okay, now it's given the question that A to C is covered with velocity v1, C to D with velocity v2, and D to B with velocity v3. Okay, now let us say that the time taken to cover was A to C t1, C to D t2, and D to B t3. In which case, and also the total time taken for this travel was t. Okay. Now let's write down what is average velocity is equal to. See, we know that average velocity is equal to the total displacement upon the total displacement, the whole upon the total time. Now what is the total displacement? The total displacement is AC plus CD plus DB, the whole upon, what is the total time taken? It is T. Now how much is the total displacement? The total displacement is AB basically, and the total time taken is the sum of T1 plus T2 plus T3, right? And how much is AB? AB according to the question is 3x, so we can write it as 3x, the whole upon. What is T1? See, for the motion along AC, what is V1 is equal to? V1 is basically equal to the displacement, that is AC, upon time, that is T1. So what is T1? T1 is basically equal to AC upon V1. What is AC? AC we have taken it as x. So this will be x upon V1. Right? So let us continue this question here. So T1, we can replace T1 as x upon V1. Now can you tell me what would be T2? Which is the motion reference from C to D. T2 would be T2 would be x upon V2, and very similarly T3 would be x upon V3, right? Going further, this would result in, let me write also 3x in the numerator, and denominator we can take x common. So what do we have rest? So we have 1 by V1 plus 1 by V2 plus 1 by V3, right? Now further we can write this as, now I don't want to solve the question in one single step because I believe these are the very simple questions, and those who are watching it are doing it for the first time. So I'm going to I'm going to write each and every question more times. with most steps. Okay, now what will be the LCM here? The LCM would be V1, V2, V3, right? And what would be the first numerator? The numerator here, when you divide V1, V2, V3 by the denominator, that is V1, what will cancel off? V1 and V1 will cancel off. So now you will multiply the numerator with V2, V3. V2, V3 plus what will be the LCM? The LCM is V1, V2, V3, and what is the denominator? It is V2. So what will you divide it by? You will divide it by V2. Now what will cancel off? V2 will get cancelled off, and what else will you get here? V1, V3, right? So you multiply the numerator with V1, V3. So here you write it as V1, V3. We don't need to do the third part. It would be V2, V1, right? Now, in this case, we can say further that x and x will get cancelled. So what will we get? 3 the whole upon. Let me just make a small rearrangement here. I would write it like this. V1, V2 plus V2, V3 plus V1, V3. Okay? The whole divided by V1, V2, V3. Okay? Now, this can further be written as 3 times V1, V2, V3 the whole upon V1, V2 plus V2, V3 plus V1, V3. So the average, this would be the required expression for the average velocity.